Guys, so we have to simplify this rational expression. Again, rational expression is when we have fractions, okay, where we have an expression on the top and an expression at the bottom. So this is a fraction here, all right? So the expression on the top is 2x squared minus x third minus x to the fourth power over x to the fourth power minus x to the third power. Of course, when you look at this problem, some people will be so happy that it's going to be a quick fix. Okay, so that we think about just take the negative x to the fourth and x fourth, cross them out, and then take the x3, negative 3, x power 3, and then end up with 2x squared only. And then bingo, we're done. All right, that would be so wrong. Guys, that would be so wrong. All right, so let's take a look at the problem here and see what we have. So the first thing we got to do is to take the problem separately. So the top expression, we take it, and then we try to break it down. By doing what? Factoring. All right? So a lot of times to break down an expression in these cases, you got to factor them. So how do we factor this expression? So let's take it and see what we have. So we have 2x to the second minus x to the third minus x to the fourth. Now we see that the variables with the exponents is going from 2, 3, 4. But a lot of times when it comes to these polynomials, it's the way around. Okay? It's just like, from the highest to the lowest, okay? So let's do that also in this case. All right, so we rewrite this expression, which is equal to then negative x to the fourth power, negative x power 3, and then plus 2x squared. Now, the common mistake that people also make is when we have these kind of problems, when we take the negative x to the fourth that we move to the front, we do not take the sign with us. We take only the x to the fourth. That would be also wrong. So the best thing to do is always take the sign, carry the sign with you when you are moving. So this one is negative here, this one is negative there, and then this one is a positive there. So that's what is happening. So that's the first thing to do. Now the next thing to do is how do we then factor this problem? So we see that there is no common coefficient numbers that we can pull out. There is none. So what we're going to do? So we're going to work on the variables. So we have x to the fourth, x to the third, x to the second. What's the greatest common factor when it comes to these problems here? It's going to be x to the second. And a lot of times, for greatest common factor, the one with the smallest power is always going to be your greatest common factor. So the one with the smallest power is x to the second, so it's going to be x to the second. And also, ladies and gentlemen, a lot of times when the term here has a negative sign, it's better to pull out the negative sign also. Okay? So that will give us then negative x to the second. All right? So that we can make this one term here a positive. That's the reason why we're doing it. So then you divide everybody by negative x squared, negative x squared, negative x squared. So what's happening once you do that? So negative out. So x to the fourth, x to the second is going to give you what? X to the second. Okay? And then what else? Negative out. So that will give you positive here. And x to the third, x to the second, that will give you what? X only. And then here, positive divided by negative is going to give you what? Negative also. X second out. So you have 2 left. Okay? See what just happened? Bingo. So we just factored this one by using the greatest common factor, GCF. All right? So after you use GCF, okay? So after you use GCF, you see we still have 3 terms in here. Okay, for the trinomial. So remember, guys, trinomial, when we dealt with them before, in our previous video, you can always go back to our YouTube channel, and then you tap in there, factoring trinomials, you're going to see them coming out. So what's going to happen then? So if we have this one, then how do we solve for it? A quick fix, a quick one is using the AC method, okay? Even when A equals to 1. So 2 numbers that will multiply give you negative 2. And the same 2 numbers add up give you positive 1. Okay, you guys remember that, the AC method? All right, so that's what we're trying to apply here in this case. So that's the AC method. And a lot of times, AC method is more used in the US, okay, in America, than a lot of other countries. So get back to our videos and then you can see that as well. So the 2 number is going to be what? So the 2 number, so if we take the A times the C here, so that is what? 1 times negative 2 which is negative 2, okay? And then, so that will give you negative 2, and then the two numbers that multiply give you negative 2, and then add up give you positive 1, which is the b, okay? So that will give you what? 2 and negative 1. Positive 2 and negative 1, because positive 2 times negative 1 will give you what? Positive 1, negative 2. And positive 2 minus 1 is going to give you what? Positive 1, the b, okay? Because the b here, there's no number, so that is assumed to be an invisible one, all right? So those two numbers will be the one to use. And then once we get those two numbers, almost everything is done with that. So you have x plus 2, x minus 1. So like I said, ladies and gentlemen, go back to our previous videos so you can look at our factoring trinomial problems. So this is how we factor such a problem on the top. Okay, so this is what we get for the first one. And that's just the beginning, because we got to do the second one also, which is the bottom piece here. All right, so if you're going to do that one, so we take the second one, which is x to the fourth minus x to the third. So how do we factor this one here? What can we do? Okay, as we can see, we have common factors, which is x3. Okay, so the greatest common factor here is x to the third power. Okay, because remember, the greatest common factor when you have the same variables that you're dealing with, the one with the smallest power is always the greatest common factor, ladies and gentlemen, okay? Keep that in mind. All the time it works. So you do that. So when you divide this by x to the third, you divide this by x to the third, what you end up with, x to the fourth divided by x to the third is x. Because remember, when you're dividing same variables, you subtract the powers. 4 minus 3 is just 1. We don't need to put the 1. That's why this one is x. Then minus x3 times x3, it crosses out. But you have to claim an invisible one, because x3 divided by x3 is what? 1. Or you can say x3 goes into x3 one time. And that's why we have the 1 there. Okay? And that's it for this one. Nothing more for the second one. But we're not done yet, because we still got to finish this problem here. So let's go at it. So we're taking the problem here now and say, now, so what we have is negative x to the second times x plus 2 times x minus 1. All right, then that is over x power 3 times x minus 1. So steps are, you factor first, and then you take, the factoring problems, the factors, you take them, and then you plug them back into the original problem. And then now you're going to see if there's anything to simplify. All right? That's why we call it simplify. We're asking you to simplify, actually. So what can we simplify? What do we see on the top and the bottom that we can simplify? What is glaring here that we can all see is that x negative 1 is out. Okay, so we can cross that out. Okay, that's equal sign here. And then what else? X to the second, x to the third. That gives us x only. So we end up with what? Negative, then x plus 2 on the top over x only on the bottom. Okay? X negative 1, x negative 1 out. Somebody can also put this one as negative x negative 2 over x. And then keep these, one of them as the final answer. All right, so you can do that. Or somebody can even go a little further and then take these and then simplify them up as well. Or somebody could have also had negative x over x minus 2 over x. Okay, so x crossed out. So you end up with negative 1 minus 2 over x. So this also is another answer for the same problem. All right, you see how math is so lovely? Okay, so I know that you guys are loving it right now. Okay.